just does not want to cooperate with you. Okay. Project 1, were there lingering questions about like ending module 1, doing project 1? No. On to bigger and better. Next episode. All right, so what are we doing in module 2? What is this one about? Yeah. Yeah, like trying to get a little bit of stats. Like now, I say now, but really this is like 5 years ago. Data science was like the thing to do. So now, I don't know. It doesn't seem as popular to be data scientist. I don't know if AI like is changing that job of like anyone can be a data scientist with Copilot. But yeah, like stats, data analysis, and these kind of things. So look at stats, do some like quantitative, and also look at categorical kind of work, like how do we separate that kind of stuff. And then our first, well maybe not your first, but at least in this class, first time that we're doing like linear regression, and we'll come back, revisit, because linear regression is a general kind of linear algebra problem. So we'll look at it again. And then some stats, generate some random numbers, and you can analyze data, you can analyze like Monte Carlo, random number stuff. Have we started like homework too? Taking a look at it. Open it up now. I'll check in, see where people are at, and see what we should be kind of focused on for the morning. Oh yeah, he's usually not a fighter. He's usually very helpful. I don't get him on fire. I'm also very enthusiastic. Okay, yeah, that makes more sense. So I'm skipping like right into that second reading. Seems like people are kind of just getting the lay of the land, like figuring out what is module 2, what am I being asked for here. So I'm just gonna run all these cells and then we'll go back up. Let's zoom out a little bit. And you know what, let's do this. All right, so in this like second reading, through some stats and kind of working on stuff, we end up with this plot of IBU and ABV of all these different craft beers. What is this showing? Like what, based on what you're looking at? Like, is there something that's clear to you? Is there a trend that we're showing? Like why in this reading, you're kind of like going through a whole bunch of code and analyzing data, and the final result is this graph. But why? Why do that? Why would you like aim to make something like this? Yeah.
It looks like a lot of beers are clustered in one area.
Okay. What is this like clustering? What do you think that is?
Guessing that's multiple different kinds all being similar to each other.
Okay. Yeah. Yeah, so we have like different kinds, right? Because it says American IPA, American Double IPA. So there's different types of beer. All right. So there's some kind of clustering. What are they clustering? Like, what's IBU and ABV? What is that?
It kind of seems like as alcohol by volume goes up, bitterness also goes up.
Okay, so alcohol by volume is our x-axis. Bitterness, so like the bitterness of the beer, seems to generally, like, if you get up here, there's not many low bitter, high alcohol beers, at least from this like investigation. What do you think? Why are all the bubbles like different colors and different sizes? What do you think that is? Yeah.
Like the amount of purchase as a time.
The amount of what?
Like the amount of beer purchased as a time.
Oh, okay. So maybe like volume of sales for that type of beer. That's a good guess. I like that. That would be an interesting thing. That's not what this is. At least there's no like data on sales that we have in this data set. But that would be a cool thing to visualize with the. Yeah.
Maybe it's the variation in measurements.
It could be, so maybe that, like, the bigger the bubble, the more, like, the bigger the standard deviation. Do you think standard deviation for alcohol by volume and IBU is equal? Because they're all like uniform circles, right? Yeah, so it might be. Yeah, and part of the reason I'm asking this is like, as you think about what it might be, hopefully you're also thinking about like, I would do it differently. Like this is what I would want this, maybe colors to represent one thing and size to represent something else. Or, yeah. Yeah, so like there's a whole bunch of different American IPAs, so there's probably a whole bunch of different values that all led to this one point. So I guess there's two parts to this: the size of the bubble and then the location of the bubble. What do you think the location is telling us? Of like the fact that American IPA is here at 70 IBU and 6.5% ABV. What is that? Does that mean every American IPA is 6.5% alcohol? What is it?
It's like the average American IPA, is that?
Yeah, so it's probably the average. Like there were probably some that were down at 4, some that were up at 10, but on average 6.5 is the American IPA versus like an amber ale is like 5.5%. And then same thing for IBU. There's probably a whole range of values, and they all got squished down into one. So one way that was brought up is like, oh, if we had ellipses, we could visualize the range of values between them. So it would be like big, tall IBU variation, and then a little squeaky, like alcohol by volume variation on the other side. And in this case, it's actually like the number of beers that were counted in that. So the size of the bubble is roughly like n. If the mean is the sum of the values over n, the size of the bubble is like how many we actually counted. So really small ones might be down at like 1 to 2 or 3, and real big ones are maybe 20 or 50, 25. And that's what, if we kind of dig into this scatter plot code, let's put stuff on a couple extra lines. X is that alcohol by volume, then it's IBU. The style, so the size, S, is the size of each marker. That one is style count, so like the number of beers that were counted in that style of beer. And then colors, that one is also based on like style counts. Which we could, I feel like it would be better to do it by, rather than having, I feel like it would be better to have categorical, like a blue is an IPA, a red is a something, but this is just how we did it in this first round. All right, so then let's look at the other side of the process. So on the other, without like visualizing this data, the table of data that we have is, catch up. Table of data that we have has 2,400 different beers in it. Every beer has like some kind of index. It has some alcohol by volume, an international bitterness unit, has an ID. The ID, I don't know what the ID, I think it has to do with the brewery ID. Or no, that one's over here. This one's the brewery ID. And then this one's like an ID. So each brewery must assign its own like beer identification. And it's got a name, a style, and then how big the beer is. Most of them are 12 or 16. And like looking at a table full of 2,400 values gives very little information compared to at least like all the stuff that we were kind of talking about. Like, oh, maybe this is the average values. So that's kind of why there's a lot of reasons to plot things, but one of the main ones is like try to make a story out of that data set, or kind of so then in the homework, we'll load in that same beers data set, but we'll also work on another data set called like transistor data that has all the different like the number of semiconductors that were put on each microchip from 1970 up to 2020, I think, is the latest. Looks like 2019 was the latest one. And first thing I ask you to do is just like this command head. So it's called a bang operator, but that exclamation point, bang, like get out of Python, access your like underlying computer code, like whatever operating. Here we're running Linux, so it has a head command. In Windows, there is no head command. Like the terminal in Windows doesn't have like this command. I don't know why. Like it's such a useful command line thing to use, to just like, all right, show me what the top of this data file. But in Windows, I think you have to print out the whole thing, so all 2,500 rows. Huh, what are you gonna do? And reason I always do that is like this first row is really like usually the labels. If you think of it as like an Excel file, because here it's a comma separated value file. So usually that's the labels of like, are there units involved? What are they called? All of that. And that way, when I load in, when I create like a pandas data frame of that comma separated value, I can double check, like, did all the headings transfer down? Is this what I was expecting? And if there are errors, usually there's some kind of errors, or maybe there's missing values. Is that what I wanted? Like, should I have missing values? Do I care about all of these things? Like, not really. There's only really I care about designers, transistor count, and date of introduction. Maybe the processor would be kind of cool to hang on to know about, but and you can kind of organize things with pandas data frames this way. So what if I want to find how many missing like values there are in this data set? If I ask for like, hey, show me, well, here I can say, show me the column, like just that MOS transistor count. It shows me like, hey, it's you created a new data frame. It has one column and it's got all this stuff in it. The name is MOS transistor count, has 186. Can I just look for like when is a value missing, like an NAN? I can try it. So then it tells me NAN is not defined. Like, okay, well then do a NumPy NAN. I get a whole bunch of falses. So let's sum. A false is 0, a true is a 1. So if you look at the sum of all the trues and falses, it tells you how many times it was true. And according to this, there are 0 missing transistor counts. Seems weird, because they were definitely missing ones, right? Like we looked at them, we saw them. I mean, here I'm counting 1, 2, 3, and there's probably more as you go down, right? So something's weird with that equals sign. So let's do a little check. Does a NAN equal a NAN? No. That can't be right, right? Like it's exactly the same thing. Left side equals right side. And yet, no, it's not true. What am I doing wrong? What's wrong with this? So here's an example, like here, 2 over 0. No. Division by 0. I just want the I was gonna show you like a 2 over 0 isn't missing value, but it's not, it just gives you an error. I thought there was a way to do it. Oh, there we go. If we say like infinity over infinity, that's not a number. And it's still, because if I said, so one way to think about this logic of like try to make some sense out of it is like if infinity over infinity shouldn't, like there shouldn't be a number there, then 100 times infinity over infinity is the same thing. Like there's no difference between like that missing value and another missing value. So you can't have like an equal sign to evaluate. Is this thing non-existent? Does it equal a non-existent thing? Well, I guess, maybe, no, not, kind of. So instead we have to come up with a different, we use this, isnan. Like, is this missing? That we can look at like true false for that one. And this one, I think we can also say is NA. No. Try that first. This one always confuses me because NumPy uses is NaN, Pandas uses is NA. I wish they would just add both to both so that you can use whatever you want, but maybe that'll be one day. So now we can figure out how many times did we have a missing value. There were 7 missing transistor count values, and that's what I was looking for. Bless.
So right now, like you're in a server,
Yes.
and the server has access to like, these files down the bottom.
For lab classes, I have like an Excel folder for the lab. I can just open that. Like
Yeah.
not in here.
Yeah, like in Jupyter, you can upload files into your, even if you're using a remote server, or if you have, if you run it on your own computer, you can access whatever files are already there. Are you trying to do other data analysis too?
In my lab, we had to upload like 5,000 data points. And we're using Excel for that, so I was just curious.
Yeah, this would be great for Excel kind of blocks down. You get over 1,000 rows, I think, a year. And this has no problem with tens of thousands of data points.
It's also really recognized as
Oh yeah. And you can now use a whole. Yeah.
and there were 3,500 of these data points. I need to upgrade us.
Yeah. When graphics cards were cheap. Oh, reading coach. That one should be in less than. Oh, it should be on. That one over there on the left. Nice, nice. Okay. How do you like using the learning coach? Yeah. Yeah. Okay. That's pretty cool. Yeah, it does. Like it feels good when you're using it. Yeah. Yeah. Yes. Yeah. That part, what I found is like 85% of the time it does tell you the right information, but then there is 15% kind of pepper in there randomly where yeah, it's all over the place. Okay. Yeah. Yeah, that's good. Yeah. In Copilot, like you should be able to like build your own agents. Could give it like a PDF from the class and say, you're now my TA for this class. Yeah. Yeah, no, PDFs work okay. Those you have to upload like each time. But then their website, your agent can like go to a certain website and be an
So another reason, got a couple of minutes, so we'll give this a shot. Another reason to like look at data like this is you can kind of mix old and new. This head command is probably a command that hasn't changed in 40 years. It's just been on Linux and Unix computers for decades. But it gives us just enough information that AI could look at this little standard set and then tell us how to process this data, however we want to process it, right? So let's go into Copilot. Again, I don't have any specific AI that I think is better or worse. Copilot, we have unlimited access to, and you can like create your own agents like within Copilot, just because that's our Microsoft Yukon account. So let's go into our module 2, like agent. It's learning coach. We're going to learn. Oh, that should say module 2. I have a data set. Here is the first 10 lines. I need you to use pandas. In here, like we've done a little bit of the pre-work because we already chose like, all right, let's use an agent. It already has kind of some stuff that it's going to retrieve to try to make stuff. So then I pasted in just that output from my head command. It's telling me how to load the data. And it's even saying like, without knowing, I guess it has the readings, like it knows what this reading is about. So immediately it's telling us how to create a scatter plot of like date of introduction and transistor count. So let's just copy it and see what it does. Oh, data would help, right? Oh, it didn't show us how to get the data, right? Oh, that's weird. It's trying to like take that whole, it's trying to take what I gave it and turn it into a CSV. So let's just grab this one. So it gives me like frequency, some kind of histogram plot, and it gave me this transistor count over time. It's not, doesn't really help because what it looks, at least from here, it looks like nothing happened in the computer industry for 40 years, and then in 2010, all of a sudden, we learned how to make computers. So it's like, well, it's not really the whole story. It's that everything was growing on a log scale, like microchips. If you think about like how many transistors you can fit on a microchip, it's like as you double the area or make them smaller, like for the same amount of area, make them a little smaller. Now you can fit, if it's, kind of double size, really it's 4 times as much, or 10 times is really 100 times. Like area scales pretty quickly. area and volume. So let's go back. It's like, great start with plots, but I want a log scale and a way to tell who made the transistor or who made the chip with the designer. Log scale, color-coded designers, makes sense to me. So let's just grab it, see what happens. And I'm just gonna delete all that. Oh. Maybe not everything, everything down here. That's weird. It's not log at all. Key error WDC. I don't know what that means. So we'll tell it. I get an error. So designer colors didn't include WDC, so then I can go back. Oh, now it's trying to give me a quiz. You didn't even fix your own problems, AI. Don't give me more problems. All right, let's try this one. It's getting better, right? Color-coded. It's on a log scale. Looking pretty good. And I mean, this part, we could keep kind of iterating back and forth. Like, hey, make the legend like 2 columns or something, or put the legend below with like, 10 companies per row, something like that. Let's go. Oh, sure, let's do it. All right, I know, it's time to go. That's right. Sorry, I got too into it. Thanks so much. Have a great weekend. And on Monday, we'll be back, do some more data analysis.